In this problem, we are given the following diagram here. We need to use the step functions to write the expressions for our waveform. So this represents a waveform. And then we are given intervals here for A, B, and C, different intervals, and we need to write them. Now, the step function for this is that our f of t is equal to our mx, or our mt in this case, because our t is equal to x. Keep in mind that our f of t is equal to our y as well, plus b. This is going to be in parentheses multiplied by the bracket of our u and then our t minus a. And then if we have another t value, which we do, or I'm sorry, another a value, which we do, we're going to have a minus u and then a t minus a, and then close this off. So that is going to be the equation that we are going to use. So to find these, all we have to do is separate our actual waveform into the specific parts that are different. So we can see that it's different from 0 to 2, then it is from 2 to 6, and then it's also different, well, it's the same from 0 to 2 as it is from 6 to 8, but it's different from 2 to 6. So these are going to be the three different parts of our waveform, and then we can just plug in our actual values. So this value here and this value right here for our A, B, and C are going to be our A's. So that's what their A is. And then we can just plug them into our equations. So the first A is going to be 0. So this one right here, if we reveal it, it's 0. And then this one should be a 2. So we have a 0 and a 2 for A. And then if we do this again for this one, we are going to have a 2, and then we should have a 6 because of this. And then looking at this one, if we delete these, we should have a 6, and then we should have an 8. So that is how we would solve this problem. Now, if we weren't given the actual slope, for each of these, we are given a slope right here. However, if we weren't given to it, it's easy to find. We're just going to use the slope formula, so we'll kind of bring this down. It's going to be y is equal to mx, or mt in this case, plus b. We know that our m is equal to y2 minus y1 over our x2 minus x1. So we can just plug in the values of our actual part right here. We're going to use this slope. So our first y is going to be the 10, our second y is going to be the 0. And then our first x is going to be the 2, and then our next one is going to be a 0. So this is going to give us a 5, meaning that our x is equal to 5, or m, sorry, is equal to 5. The slope is 5. Now we can plug this back into this equation here, and we can just plug in some arbitrary value that is in the actual slope part for our y and our t. So we're going to have t, y, and this will be equal to, well, this should actually be f of t. So we're going to have t is, so we're going to have t comma f of t. This is in parentheses, and then the points that I'm going to choose, just because of the easiest, is going to be 0 and 0. But just for better example, I'm going to choose the points 2 and 10. So you can see if we choose this point right here, it's going to be equal to this y, or this f of t point right here. If we plug these in, we're going to have 10 is equal to our 5 times our 2 plus b. If we subtract this out, we're going to get that 0 is equal to our b. So when we write our slope formula, we are going to have y is equal to f of t, and this is going to be equal to our slope, which is 5, times our t plus a 0b. That means that our f of t is equal to 5t. So this is the slope for this first part, and that's how we're given it here. And that is how you would go about solving this problem, and that is more information on the slope. If you want notes for this problem, they're in the description below, as well as a playlist with more network analysis problems below the like button.